Okay, good afternoon. Today I will continue the FET, the introduction of FET. After we learn about the GFET, in this time we will learn about the depletion type of Mosfet and enhancement type of Mosfet. So you can see from here, this is the N-channel depletion type of Mosfet. Okay, we have three terminal like a GFET, source, gate, and drain here. And then this is the N-type. N-type is mean that we will design a channel between the source. This is the source, so this is the source, and this is the drain, and this is the channel. This is the channel. So if we control the gate using the voltage, we can control the channel between the source and drain. So the current will flow. This one, this is the current from drain to source. And then this is the insulator. So this is the insulator. Okay, so in the insulator is very desirable high input impedance. So we can see that the input resistance of the Mosfet is similar to the GFET, but the input impedance of the Mosfet is high for the MOS application. So we can see from here, because the insulator is located in between the gate to channel, so the current of IG is essentially the 0 ampere or for the DC biasing configuration. Okay, so this is the basic configuration operation and characteristic. If we control the voltage of gate or VGS, voltage between the gate to source, so we can control the current or ID. ID is drain current, or similar to IS, and ID similar to IDSS, or ID is when saturation. So when the gate to source voltage is set to be 0 by direct connection from one terminal to the other, so we put here to the ground, so it means that the VGS is equal to 0. And then the voltage of VDS is applied across the drain to source, so we applied this one, the VDS here, or VDD, drain to source currents. So it so we can see that this is the positive. This is the positive here, and this is the negative here. So the current will flow through the channel. Okay. So because in this type depletion type is the channel is formed located in below of the gate, so the current will flow. So the resulting current when VGS is equal to 0, so we can see this is the IDSS, is similar to the GFET. So when VGS equal to 0, so this one is IDSS. So this is the saturation current of the Mosfet. And the Mosfet has two modes. The first one is depletion mode. Depletion mode when the current of the Mosfet is lower than IDSS. This is the depletion mode. Sometimes the depletion mode located in negative if the VGS equal to lower than 0, and then the enhancement mode, another mode is when VGS is larger than 0. We can see here when VGS is 0, minus 1 volt, minus 2 volt, minus 3 volt, and minus 4 volt. So the MOSFETs work in depletion mode. And when the VGS is larger than 0, or VGS equal to plus 1, so the MOSFET is working in enhancement mode. We can say it's similar to GFET. If we would like to draw the circuit characteristic, the first one we have to see when VG is equal to 0, ID is equal to IDSS here. When ID is equal to 0, so VGS is VP. VP is minus 6. And then when VP is when a half of VP, or VP per 2, and this ID is IDSS per 4. So here, for example, and then when VGS is 0.3 VP, so ID is IDSS per 2. So if we have 4 point here, we can draw the device characteristic like this one. Okay. So the negative potential at the gate will tend to pressure the electron toward the p-type substrate like charge repel and attracts hole. So if we put a negative here, this is the negative. So the electron will repel and recombination with the material here. This is the positive. And then if we increase the negative bias, the higher rate of recombinations. Okay, so if more negative bias, so the higher rate of the recombinations. So the electron in the channel and channel will combine the hole. So the current flow from the drain to source is decreased. So we can see if we put the negative value of the VGS, the ID is decreased like this one. Okay. But if we increase the VGS, it's like +1, like this +1 here. Okay, so the electron is attract to this one, to the below the insulator like this one. So the recombination will be lower. So the current will flow from the drain to source. Okay. So for example, this is sketch the transfer characteristic of N-channel depletion type MOSFET with the DSS equal to 10 milliampere and VP is -4. So the first one, we have to put 2 points here. When the VGS equal to 0 here, so the ID is IDSS, okay, is here. And then when VGS is VP of -4, ID is equal to 0, okay. And then when VP per 2, so VP per 2 is -2 because the VP is -4. So -2 here. ID is IDSS per 4. So IDSS is 10 per 4 is 2.5. So this one. And then when 0.3 VP or 0.3 is -1.2 here. So IDSS ID is IDSS per 2. So it is 5. So we can draw this characteristic. So this is the device characteristic, and we also can use this device characteristic to see the enhancement mode. By using the VGS +1, for example, we get that the ID is 15.63, so we can see this device characteristic. Okay, so this is the p-channel depletion type of MOSFET, similar to the negative, the n-channel. We have to draw 4 points. It's like here, 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 and here. So we can draw the characteristic. This is the N channel, and this is the P channel. Okay, this is the depletion type MOSFET specification sheet. You will see in the lab. And then after depletion mode, this is the enhancement type of MOSFET. The differences is in enhancement type, we didn't have the channel under the gate. So if you look the depletion, so this is the channel here, okay. And in enhancement mode, there is no channel here. So the channel will form when we applied the voltage in the gate, like this one. It applied voltage, we will make the channel between the drain to source, so the current will flow. Okay, so like this one. So if we put the positive VGS here, this is the positive. So in this one, this is the positive, 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 positive. So the electron in the p-type will attract to the gate. So it's like they form the channel here. So the electron in the n-type of source will recombine with another electron to the drain, or the current will flow from drain to source, like this one. Okay, so imagine if we put more positive voltage, so the channel will larger, so the drain, the current from drain to source will be larger. or increase. Okay, so we can see here when VGS is equal to +3, if increase the VGS, so the ID also increase. This is the ID also increase because the channel will larger. Okay, and then in enhancement type MOSFET, we also have the pinch off. Okay, like this one, the pinch off. The pinch off is happen when we increase the VDS. Okay, when we increase the VDS, the first one, the current will flow in this active region, and then after the some point here, like 6 volt here. So this is we call the saturations, and then the channel will like a pinch off like this one. So the current will saturate. So and then the current didn't increase, but it just like a remain stable like this one. Okay, so this is the pinch off or saturation region. Okay, and similar to the depletion type of MOSFET, we have to draw the characteristic of the enhancement MOSFET by using this equation. ID is equal to K VGS minus VT quadrat, and so the K is ID on per VGS on minus VT. VT is threshold voltage quadrat. So maybe this is the example here. Okay, so this is the specification, and this is the N channel and P channel. So you can see the differences between the enhancement type and depletion type symbol is here. This is the dash line for enhancement type, but for depletion type, the symbol is not dash. It's like solid line like here. Okay, so this is differences between the enhancement and depletion type MOSFET. Okay. So this is one example of enhancement type using the data provided on the specification sheet. Draw the VGS threshold is 3 volt. What is the K? So the K is this equation ID on per VGS on minus VGS threshold quadrat, and this is 6 specification sheet here. So ID on here is 3 milliampere. Okay. Okay, when VGS on. Okay, so how? Maybe you. Okay, here. So when on state, so see the on state then current here. When VGS equal to 10 volt here. So the ID is 3 milliampere. So we can see here ID on 3 milliampere. When VGS on is 10, so VGS threshold is 3 volt here. We can see that K is this one, 0.061 multiplied by 10 power of minus 3 ampere per volt quadrat. And draw the transfer characteristic. ID is this equation, K VGS minus VT quadrat. So we using this K, and then VGS is and VT is constant. We can see for VGS equal to 5, ID is 0.244 milliampere, and then we also have to check in another value of VGS like 8, 10, 12 volt to get the ID. So we can sketch the device characteristic like this one. Okay. And another type is VMOS. VMOS is like vertical MOSFET. You can see here, this is the vertical. This is the drain, and this is the source, and this is the source, and this is the gate. The operating principle of the VMOS and MOSFET is similar. But the VMOS have the reduced channel resistance level and higher carrier and power ratings. Okay, here maybe you can see if we use VMOS to replace the MOSFET, the dimension of the device will smaller, because we not only using the planar is mean that it's like the planar, but we use the 3D model, like in the upper is source and gate, and the bottom is the drain. Okay, so we can decrease the dimension of the device by using the VMOS, vertical MOSFET, then the MOSFET and GFET. Okay, so this is the example. If we use the CMOS, CMOS is complementary metal oxide semiconductor. CMOS consists of two MOSFET, the P-channel MOSFET and N-channel MOSFET in similar in similar circuit. So we have here is P-channel MOSFET, and this is the N-channel MOSFET. Okay, one example of a CMOS inverter like this one. So this is the P-channel, and this is the N-channel. Okay, so you can see here how we can design the inverter using the MOSFET by following this explanation in this slide. Okay, and then the last one is Mesfet. Mesfet is metal metal semiconductor, FET. The differences is we don't have any insulator below the gate. So this is the gate, and then this is the metal. So below the gate there is no insulator, so we call it a Mesfet. And then the device characteristic is similar with the Mesfet. This is the summary. This is the for GFET, and this is the MOSFET for depletion type, and then this is the MOSFET for enhancement type. This is the equation how to find the device characteristic, and this is the Mesfet for N-channel, Mesfet and N-channel depletion type, and Mesfet for N-channel enhancement, and this is the equations. Okay, I think this is the introduction of FET. I hope you have a clear enough for this session. Thank you very much. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.